next topic. So we look at briefly, I think we have another 10 to 15 minutes in today's class. So let me get started with 5G system architecture and see what are all the things that are there as part of the 5G system. So before I talk about the 5G system architectures, let's quickly recap what are all the high-level requirements for the 5G system architecture. The first one is the 5G system should support new radio access technologies. It has to support also the evolved 4G, and also it should support non-3GPP access type. That means 5G system architecture should support not only 5G NR, it should also support 4G, and also it should support Wi-Fi and tomorrow maybe satellite systems as well. So that way the requirements are quite broad and encompasses all different kind of access types. And it should support unified authentication framework for different radio access technologies. So whether you are using 4G or 5G or Wi-Fi, from the user point of view, you should be using only one authentication method. Maybe all of you know, right? In the cellular, we use the SIM card for authentication, which has some built-in keys in the SIM card using which we do the authentication with the core network. Same thing can be applied irrespective of whether you're using 4G or 5G or Wi-Fi as part of the 5G system. That is the meaning of this. And it should also support multiple simultaneous connections of any user equipment via multiple access technologies. This is very significant. So what it basically means that a handset or the user equipment can connect with more than one base station or one access point simultaneously. So you can think of your handset is connected with a 4G base station and 5G base station, or it is connected with a 5G base station and a Wi-Fi access point simultaneously, where some traffic can be routed through 4G, some through 5G, and some through Wi-Fi. All of them should be possible. That we are talking about something called multi-access connectivity as part of the 5G systems. Separation of the control plane and data plane. This is where I was talking about in the previous class about adopting SDN principles, the separation of the control plane and data plane, so that both of them can have independent evolution. And yeah, this also related, and leveraging technologies like SDN and NFV, which have been already tried out by ISPs and also in the internet world, to reduce the capital expenditure and operating expenditure, and also improving the flexibility to offer new and diverse services. So with SDN and NFV, we can able to significantly cut down the cost. Because of that, operator can venture into trying out new services on the fly rather than feeling the pain of investing additional money for deploying new services. So SDN and NFV, basically it means that you don't have to buy one more appliance. You can create one more virtual machine or container and launch instances by getting their new services as software implementations rather than buying them as middle boxes. So that is what it says. Efficient support different levels of UV mobility and improve energy efficiency. So you should able to provide uninterrupted connectivity for the users during the mobility, and also should have high energy efficiency. So here we are talking about energy efficiency more than what even the 4G provides as of today. That way you can improve the lifetime of the devices. And again, related, support different means for reducing the UV power consumption. So do your best so that we can increase the lifetime of the mobile phones. Minimize the signal overhead and reducing the latency for starting of data transfer. So many times what happens is you don't know where all these networks, especially the cellular networks, are very notorious in terms of the signaling overhead. So when you switch on your mobile phone or when you switch on your data and before you send, let's say, WhatsApp messages, there are hundreds of control messages that get exchanged between your handset and the base station and the core network. You don't realize all of them because all of them are meant for providing you the link and doing the authentication and all other control plane related activities. But the idea is, in spite of having these many number of signaling messages that are exchanged, you wanted to have your data transfer happening in a fraction of the seconds. That is the objective here. Supporting network slicing and dynamic scaling in and scaling out. Network slicing is basically talking about creating virtual networks for catering to diverse use cases. That's what I was talking about, where EMBB, URLLC, massive, MTC. And also dynamic scaling in and scaling out, where we can able to increase and decrease the resources. Not only when I say resources, it could be the channel bandwidth that is configured at the base stations. If the user traffic is increasing, you can configure base station with a higher channel bandwidth with massive MIMO kind of thing. During off-peak times, you can scale down the bandwidth, and also you can reduce the MIMO configuration from 64 by 64 to, let's say, 8 by 8 or 4 by 4. So what is the significance of scaling out? By scaling out, we can improve the energy efficiency at the base station, because unnecessarily you don't want the base station up and running all the time and waiting for the users. So during off time, off peak seasons or off peak hours, we can do these scale out to reduce the operational expenses for the operator. Scaling in is where during the peak hours and during festival seasons, where the operator wanted to cash in on the demand for the data by deploying more base stations and virtual machines and containers, so that we can do the load balancing and other things. Support critical communication, including mission critical communication. So this is one of the new requirement to cater 5G networks for machine centric communication as well. Whereas up to 4G, we are mostly talking about human centric communication. With this, we can talk about taking 5G also into factory settings and autonomous vehicles and other use cases. And one other important which no governments want to leave out is supporting regulatory requirements for lawful interception and public warning system. Yeah, public warning system is like when there are tsunamis, earthquakes, or when there are any major thing, we can also send a push notifications from the base stations, so that you can able to quickly get to know what is happening rather than waiting for the news to be relayed through television. And lawful interception is about when there is any incident, the law enforcement agencies wanted to get to know the unencrypted data that you have exchanged with the network, so that they can able to see whether anything mischievous is being done or any anti-national activities are being carried out using this particular network. So that is a mandatory requirement. So that is kind of having a backdoor to the technology, so that government can swoop into. Again, one can debate about whether you should allow it or not, but so this being something that standardized and regulatory have to give their nod. So there is no escape for this kind of requirement not to be there as part of the requirements. So these are some of the issues. I am not going to enumerate all of them. Basically, these are the key issues that 3GPP has kind of looked at when they are defining 5G system architecture. Okay, so let me skip this part. You can go through it later. Okay, so let me stop today's class by showing you the 5G system architecture. So it looks very simple as you see here, but behind the scene, you have all the complexity hidden under all these clouds. So let me talk about each of them. So this is the user equipment. So this is like your smartphone or your IoT device or your autonomous vehicle fitted with 5G radio. Okay, that is what you see here. So this is called NG-RAN, which stands for Next Generation Radio Access Network. So here it is being shown as two components, where the RAN is split into two parts. One is called the central unit, the other one is called distributed unit. But in general, you can think of this as something called G node B. Or in other words, base station. So up to 4G, we have something called base station. That's what you see when you look at the towers. We have the towers which are fitted with antenna elements. At the base of the tower, you have a small box. Inside, you have this base station running with the entire protocol stack. So up to 4G, the base stations are monolithic, which are deployed at cell sites. That means on the ground or on the top of the buildings, wherever they get license to put their base stations for providing cellular connectivity. But in the 5G, what is going to happen is base stations are also kind of split into 2 to 3 parts. So at the high level, you can think of base station is split into 2 parts, where the protocol stack of the base station is split between central unit and distributed unit. That's what we are going to talk about as part of Cloud RAN. Cloud RAN. So before Cloud RAN, we have something called Central RAN, where Central RAN is talking about taking some part of the base station and putting in a central remote location, and rest of the base station stack will be running at the cell side along with the antennas. But anyway, the point is the user equipment that you see it here, they are connected wirelessly to the base station. So that is one. So base stations are the one that are there as part of the NG-RAN system. Whenever we say the radio access network, we are talking about collection of base stations that are deployed by the operator for providing cellular services, where the handsets are connected to these base stations to get their data connections. Then the base stations are in turn connected on the right-hand side to something called 5G core network. So as the name says, it is like a kind of heart of the operator's network, which do all kind of activities like registration of the users and billing related issues. When you want to do the deep packet inspection and routing and other things, all of them are kind of done as part of the core network. So where you see as in the illustration, the 5G core is separated into control plane and data plane. So you see at the bottom there's a user plane, and at the top you see control plane. That way, SDN principles have been nicely adopted as part of the 5G core. So these two together, the 5G RAN and 5G core, are together called as 5G system. When I say 5G system, it composed of 2 components. One is the RAN and other one is the core network. Where in the RAN we have base stations which let user equipment connected with them, where these base stations are in turn connected with the core network. So core network has something called user plane function. We can assume it's more like a router for routing the traffic. As you see, since it is a router, this router is connected with a data network. For example, this could be your internet, or it could be a corporate network. And this is a core network, and operators can have their core network, the control plane can be connected with other operators if they have any kind of agreement, or it could be the same operators 4G network kind of thing. So that is a link that you can see it here. But when you're talking about you accessing, let's say, YouTube or your WhatsApp or Facebook, the data goes from the user equipment to the base stations, base station to the user plane function, that is nothing but a router. From then it will go to the internet. And then you see things happening in the reverse direction as well. So let me stop it here. In the next class, I'll go and talk more about how we can deploy these base stations. There are many different configurations we can use it to connect the base stations. And I was also talking in the previous class about something called standalone and non-standalone, where we talk about the 5G base stations acting more like kind of a secondary or supplementary services to the 4G, and even the vice versa, that is also possible. So that way there are multiple different configurations that have been defined, so that operators, whoever currently deployed their 4G services, can able to seamlessly transition into the 5G. So the manufacturers of these 5G equipment want to make sure that the 4G operators can able to upgrade to the 5G networks with minimal disruption and with the least amount of the investment. Otherwise, there will be a lot of resistance from the operators to embrace the new technologies, even though they're meant for providing better coverage and high data rates, because they have to get their return on investment on their 4G. So you see in the following class how 4G and 5G can be nicely married together so that operator can do mix and matching as the systems evolve towards 5G. And at a later points, they can also discard their 4G networks and completely move on to the 5G, or maybe even think of 5G as the main and 6G as a supplementary as we go towards 6G networks too. So we'll discuss that in the following class.